Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the Bommer LB8006-450S-630. This is a security stud hinge, is what it is. This is a hinge that is an otherwise fairly common, typical sort of hinge that you'll get from Bommer, in the sense that it's just 4.5 by 4.5, and it's of a bearing construction. This happens to be a 3-knuckle hinge, not highly unusual, but the S in the part number, the 450S, that's what makes it unusual, at least uncommon. You don't see security studs often. Okay, so a security stud hinge, and we're going to talk about the regular profile of this hinge, meaning its characteristics, its description. But let's talk about the thing that separates this. So it's that stud. You'll notice that there's an extra hole over here. When that door closes, that stud occupies that hole. Okay, so what happens is this. If I were to drive that pin out, because that stud is sitting inside of that hole, the concept is I still can't pull the door out of the frame because of the projection of that stud. Okay, let's get a couple of dimensional properties on it. Now, I've seen these hinges out in the wild. Some doors in the American terminal in Miami International Airport. If you've flown through Miami American, that is the largest terminal I have ever seen in terms of a single airline. It's you plan ahead if you got to go from the beginning of the entrance to gate 85, whatever it is. The projection of this stud is 0.187, so 3/16 projection. The diameter of this stud is 0.375, so it's 3/8 diameter. It's 3/16 projection. That leaf, that swag on that hinge leaf is going to leave you, when that door's in the closed position, it's going to leave you with basically 1/8 of an inch projection of that stud into the opening. So what you're really going to need to do, in order for you to get that door out of the opening, and I can't illustrate it here because I'd have to separate the leaves, but in order to get that out, you'd have to really open up the hinge prep, except over on this side. So this V profile, imagine that it was symmetrically opposite, where it was open up here and closed down here. You'd have to really open that up in order to get that door to come out. In order to get that door to, to be able to motivate it to come out. And I've never tried to tear a door off the hinges with a security stud. But I would imagine that you're going to have quite a time doing that. Security studs are, in my opinion, best used in combination with NRP, the N. So this would be an NRP model where you would have a hole drilled and tapped for a set screw into the pin of the hinge. And you'll see those two options used together, especially in applications, and some manufacturers may call it maximum security. But a security stud is really an effective means by which to keep the door in the frame. Okay, even if you drove that pin out, you're going to have to be quite determined to be able to move to create the amount of room necessary. I don't see it realistically happening. If you had extremely poor knockdown drywall frame construction, I don't think that's going to be too much of a major problem to get a large cold chisel in there and hit it with your 5-pound mini sledge and be able to slam the gap over, because you're just destroying the frame. But in exterior walls that are masonry with grout-filled frames, that frame's not moving at all. The door's not going to shrink in size, and a security stud is going to be extremely effective. So where would you use it? Obviously, exterior doors that swing out. Okay, from the outside, this is all you're going to see. Okay, you are literally not going to have any evidence of the security feature of this hinge. And I'll tell you this, it's a beautiful hinge on the outside as well. Okay, it's the LB series from Bommer is their 3-knuckle construction, and it's a nice looking hinge. Okay, what I mean to say is, in comparison to the standard, our garden variety ubiquitous 5-knuckle hinge. let's talk about the entire part number. Let's dissect it and let's move forward. Now, let's dissect the part number to find out the hinge that it is that we're dealing with here. It's an LB8006 450S 630. So LB stands for lube bearing. It is a maintenance-free sort of construction of bearing, a maintenance-free bearing construction from Bommer that inherently makes it a 3-knuckle hinge. If you have an LB hinge from Bommer, it's a 3-knuckle hinge. Okay. Now, the rest of the part number I think would be good to have a screen view so we can look at the how to order matrix. So let's switch to the screen view now. Okay, so here is the product that we're looking at, except that this is not the security stud model. But let's take a look at it. So what we want to do is get to the manufacturer's catalog, which is here. The manufacturer's page. Click on that and this page will load. Then we can pull up the Bommer product catalog. Now I also have a shortcut on that manufacturer's page, how to order matrix. This is just exactly that. They're how to order for their material, but let's take a look. Let's take a look at the cut sheet of the catalog of the LB8006 first. And here it is. It is a heavyweight, what they call lube bearing. In the part number, it's inferred that it's a non-ferrous base material. In fact, stainless steel with a stainless pin. It's a template hinge, lube bearing 3-knuckle. It's a non-rising removable pin. The pin can be removed, but it's inherently non-rising because of the construction. Over time, if you've ever seen a hinge pin that kind of works its way up, and ultimately gets really far up, that pin is, that pin rises because as the knuckles or the barrels, the knuckles of the hinge work against each other as the doors open and closed. It's kind of like extruding something. Imagine aluminum extruded at the mill where molten aluminum is sent through a die set. Or if you ever watch the Food Network, it's just making sausage. So that pin kind of gets extruded out. This would be a non-rising version. It has a flush tip pin. Okay, so let's jump to our matrix so that we can understand better what we're dealing with. So we have an LB. They call it lubricated bearing. The concealed lube bearing is made from a special nylon bearing material and is maintenance-free and requires little to no oil or grease. I've never heard of having to do any maintenance on an LB series of hinge by Bommer. Now, Bommer also does LB series hinges in single-acting spring hinges as well. That's also a 3-knuckle hinge. The knuckles aren't quite like this, but it's still a 3-knuckle hinge. So that's the LB. I should say that is the LB part of the part number. Then we have an 8 for a 3-knuckle. We have a 0, which is a full mortise hinge. And then another 0, which is a standard hinge. And then a 6, which means it's a heavyweight stainless hinge. So full mortise from Bommer. Full mortise is a reference to the swag of the hinge leaf. Okay, so you can see, well, it's not extremely evident here. This is a swagged hinge. Okay, so that when you see here, there is no bend or angle on the hinge leaf underneath, but here there is. That's the swag line. That will make it a full mortise hinge such that when you bring the leaves parallel to each other, you'll have a 1/16 of an inch gap. And that's typical for a hinge, of course. And then you can do other things where one leaf is swagged and the other is not. And those different swag lines on material have everything to do with the application of the hinge, such as the hinge I'm thinking of is a slip-in hinge is what I'm thinking of. Older aluminum storefront doors and frames will use slip-in hinges, where the hinge actually slides into a preparation made in the face of the frame, and then you run screws through the rabbet, and that's how you hold the hinge in. So how it's swagged is related to slip-in style hinges. And of course also, if you're dealing with a if you've ever dealt with a swing clear hinge, the factory wants to know if you're dealing with beveled leafs or not. And while that doesn't relate to the swag on the hinge leaf, it definitely talks about how the hinge is bent to accommodate the application. Okay, so full mortise hinge is what we're dealing with on this hinge. Plus, it's also heavyweight and stainless. Now, this is a 4.5 inch tall hinge, which means that it's going to be 0.180, 180 thousandths thick. I'm going to put my caliper on this hinge leaf now. And my caliper tells me 0.182, 182 thousandths. So right there, right in order with that. Moving through the part number, we're going to have our size, 450. And in Bommer speak, that means it's a full mortise hinge that's 4.5 tall and 4.5 wide. So let's, at this point, switch back to the camera view so we can talk about the size of this hinge. Now it's time for a little discussion on the size of the hinge. The hinge is 4.5 by 4.5. It's important to know that the height is the first dimension. It's 4.5 inch tall. The second dimension is the width. That's important to know because because hinges come in different sizes, and it's important to know what is being defined as the first dimension or the height or the width. It's important to know that. The height is the first dimension on this hinge. Why is the height the first dimension where doors, for instance, have the width as the first dimension? Well, I don't really know the history or, what, backroom cigar chopping committee, decided on that. But that notwithstanding, it would seem to me that the dimension, the order in which I want you to give me the information, it would be the height first. Like a door, 7-foot door. Okay, great, it's a 7-foot door. How wide is it? It's a 4.5 inch hinge. Okay, is that the height or the width? So let's define what it is. Now, 4.5 inch is the standard size that you are going to see in commercial 1 3/4 thick doors. A 4.5 inch hinge is really not appropriate for thinner doors because the location of the holes is just too wide for a thinner door. Could you force it to work? You could. It's the wrong hinge. For an 1 3/8 door, you want a 3.5 inch tall hinge. 1 3/4 thick doors will take 4.5 inch hinges. They will take 5 inch hinges. They'll take 6 inch hinges. But then the relationship to the width becomes very important. When you get into width of hinges, we're really now, when it's 4.5, we're thinking 1 3/4. If it's a 5 inch wide hinge, it's thinking, well, could be a 2 inch, could be a 2 1/4. You get into wider hinges, well, you're either dealing with exceptionally thick doors or you're dealing with a wide throw hinge where the width is wider than the height. And that's to move the vertical axis of pivoting out and away so that when you open the door, you can get out and around some sort of clearance situation that's happening inside of here. 4.5 height is a standard dimension for standard size doors. I would really consider maybe a 175-pound door in that range as the maximum that I would use a 4.5 inch standard weight on. If you get into a 200, maybe a 225-pound door, heavyweight, absolutely, it's going to make every bit of sense. And this is on the outside portion of the envelope of what you would use. If you're dealing with exceptionally heavy doors, or doors that are wider, 3'6" and wider, certainly, you'll want a 5 inch tall hinge that might be 4 inch wide or 4.5 inch wide, but 5 inch tall, because that extra ½ inch gives you about a 20% increased capacity of the hinge to just perform its intended function. So not this hinge, but a project that I'm doing, we have a pair of doors and the inactive, an unequal leaf, 3/0 active, 2/0 inactive. 3070 is the active size. Nothing unusual about that, except it's a 14 gauge steel door and it's steel stiffened. So we are literally doing a 5-inch tall, 4.5-inch wide, heavyweight hinge. And that should be sufficient for that. I expect that it will be. You get into the range of dealing with doors that are 250 pounds plus, we need to start talking about pivots or continuous geared hinges. Butt hinges aren't really the greatest option for these especially heavy doors because all of the force, all of the weight really translates to a small surface area. In fact, the top hinge alone carries 70% of the weight of the entire door. So that bottom hinge is really not doing, the middle and bottom hinge are just there for the party. They're not doing a lot of the work. So that's why hinges, when you are dealing with heavier doors, are not a great option because they don't share the load evenly like you do with a continuous geared hinge, where you have complete surface area. Or a pivot. A pivot, the weight is borne by the earth, by the ground that it's sitting on. So you're not translating any of those forces to the frame or the weight of the door to the frame itself, a la or vis-a-vis the hardware that you're hanging the door with. So be mindful of how to select that. In terms of the width of the hinge, some thought needs to be given to that because the width of the hinge has a lot to do with the proper operation of the opening. You want that vertical axis of pivoting as close to the center of the thickness of the door as possible. And let's talk about that for a moment. What we'll do is we'll switch to our screen view to take a look at why that's important. Now, a relatively quick discussion on the width of the hinge is certainly called for. Let's take a look. Why the width of the hinge is important. I'll sketch a couple of openings here and we'll talk about that. You know, 4.5-inch wide is absolutely the most common size that's around. And, you know, I was in a class and, you know, the head instructor of this, you know, advanced door detailing class or hardware specification writing, I forget what it was, basically said, you know, and this person represents one of the absolute major manufacturers of hinges and has been a business for a very long time, says, you know, you distributors, we only give you 4.5-inch wide because, you know, that's what you insist on having. And of course, a 4.5 is the ubiquitous hinge. But the bottom line is it the right hinge? And here's what we are kind of meaning. We've got a couple of different wall conditions here. One where we're wrapping the wall and the other where we're butting, you know, the wall up, you know, to the end, whether it's a T-anchor or, you know, however it's been installed. Bolted, it doesn't matter, okay? Metal stud anchor here. The point is that depending on your application, the question really becomes, where do you need to have the vertical axis of pivoting in relationship to your installation? Okay? Your door, it's going to swing out this way. Well, when that door gets to 90 degrees, you know, as we all know, it's going to encroach into the opening a little bit. But when that door gets out to 180 degrees, you know, where does that door need to reside? So you can see as the door moves through its cycle, the distance or the clearance required from the face of the wall to the face of the jamb is really important, and that's going to determine where that vertical axis of pivoting is located. Now, if you are wrapping the wall with your frame, and it's a 4.5-inch tall hinge, every single time 4.5-inch is not the right width to use, it's 4-inch. Unless there's some sort of clearance. There may be chair molding or wainscot or some sort of detail on the wall, but this is going to be most likely 7/16 right here. You know, it's most likely that's what that's going to be. So when your vertical axis of pivoting is here, you know, your door is going to easily get cleared over, what's ever here when you get that door to 180 degrees. So the point is, position the vertical axis of pivoting in the best possible location. The closer that is to the center of the thickness of the door, the better off you are with the hinge. The hinge is more capable of doing its job. But if you need to think about, you do need to be mindful of the proper width of the hinge. For this application, 4.5 by 4.5 is the wrong hinge. Maybe not the wrong hinge, but it's certainly not considered the best option. And best practice would tell us to use a 4.5 by 4. Okay, so that's why you want to be mindful of where that's located. Now, to determine how wide the hinge needs to be, that's a fairly easy concept, and the formula is door thickness minus hinge back set times 2 plus clearance plus inset. And then you round up to the next highest hinge width. Door thickness minus back set times 2 plus clearance plus inset. So if your door is 1 3/4 thick and you have a hinge back set of 1/4 inch, which is the right back set for a hinge, that's 1.5 times 2 is 3. Now add your clearance. Over here, there's no clearance. There's nothing that you need to get around. Okay? There's the inset, the dimension from the face of the door to the face of the frame, or the face of the frame to the face of the door on typical hollow metal, that's going to be maybe 3/32 of an inch. And then you round up to the next largest size available. So 1.5 times 2, there's 0 for clearance in this butt-up application, and your inset's less than 1/8 of an inch. You go to the next largest size available, that would be 4 inch. So that's how 4.5 by 4. In fact, you could get away with a much smaller hinge as well. But over here, when your clearance is, let's say that this is 8 inch CMU in a 5 3/4 frame, and it is centered in that frame, you're going to have 7.625, because 8 inch CMU is 7 5/8, minus 5.75 divided by 2. So now your clearance is 15/16. So this area here is 15/16. So it's going to be 3 inch plus 15/16 plus your inset. And that's going to put you at right over 4 inch. So you follow the rule, you go to a 4.5. Okay? Now let's imagine if that clearance, however, was 1 1/4 or 1.5 inches. Let's say 1.5 inches. You've got 3 inch plus 1.5 inches is 4.5 plus your clearance, plus your inset. That would be just over 4.5. You go to a 5 inch hinge. So depending on what the clearance is, that's going to dictate the width of the hinge. And that's how you go about determining that. If it's a butt-up style, 4.5 by 4 is the right way to go. If it's 8 3/4, if it's 8 inch CMU with a 5 3/4 frame and it's centered, 4.5 by 4.5 should work just splendidly. But nothing's to say they're going to center that frame in the wall. The point is that you need to determine what the best width is. And while 4.5 is literally the Swiss Army knife of the hinge world, it, jack of all trades, master of none scenario, you may be able to get your client into a better hinge, because you do want this vertical axis of pivoting as close to the center of the thickness of the door, just like a pivot would bear that door. That spindle point is out here, but that door is being picked up from the bottom of the door, is the bottom line. Okay, let's switch back to the camera view. Now, as we move through the hinge, we've talked about the size. Now, the security option, that is the S, that stud that's there. Now, you can also do on this hinge, as we had touched on earlier, security options. You'd be able to do a non-removable pin. That's going to feature a set screw drilled and tapped into the barrel of the hinge. Okay. In the pin itself, there will be a groove, so that when you tighten that set screw, it's going to seat into that groove, and then you can't drive the pin out. While I suppose it's possible to drive the pin out. I've tried, and I didn't proceed in doing it because I was going to substantially damage not only the hardware, but the door and frame itself. So it's virtually impossible to remove that. You can add the security stud to the NRP or use it exclusively, and that's what we've done here. You can then do a maximum security stud, where studs are attached to the back of both hinge leaves and project into holes in the hinge reinforcing plates in the door and jamb. These studs secure the leaves to the door and frame and are often used in combination with hospital tip hinges on high security areas. Okay, so that's where they're basically going to take this stud, they're going to put one in each leaf, so that when you install it, the stud's going to sink into the steel plate that the hinge is attached to. So that's going to render it, you know, if we're trying to think about separating the leaves so that you could get that what was the projection on that? Was it 3/16? That projecting stud to separate, you know, it's just not going to happen realistically. So be mindful when it comes to exterior doors that swing out. There are options. Having no security option, in my opinion, is not an option at all. Ever is the bottom line. Now we talk about the 630 in the part number. That means two things. It means that this hinge is made of solid stainless steel and that it has a brushed finish. A brushed finish over stainless is the most durable of all finishes. It's called a natural finish. It's the most durable natural finish, and it's the most durable of all finishes, natural and artificial finishes. Artificial would be plated finishes, things of that. Plated or painted or, you know, some process, powder coated. So if you say, I want the most durable finish, okay, it's solid stainless with a brushed finish. You could also do a polished finish over solid stainless, and it would become somewhat mirror-like. But people in coastal areas, you're definitely looking at using stainless with a brushed finish because the corrosion of the salt that's in the air just works, you know, wreaks havoc on everything that is exposed to that sort of atmosphere. Other options that you can do would certainly be, in no particular order, you can electrify this hinge. You can order these as half surface, half mortise, full surface. You could order these as anchor hinges, slip-in hinges I had mentioned before. You know, swing clear, wide throw, in all of the different mounting variations as well. This hinge is going to include screws. The factory has included for us what is called all machine screw, AMS, then half wood screws. There are only 4 wood screws for each hinge. The factory's really counting on you not using a wood door and a wood frame on this, to the point where they're not even supplying you with adequate wood screws. And that's their standard. That's perfectly understandable and usually acceptable. It would be considered best practice, however, to define the screw, the composition, or I should say the makeup of the screws that you want in the package. Indicate all metal screws, all wood screws, half metal, half wood, so the factory just understands what you require. You know, I've received calls on a Saturday morning and they've torn the doors out and now they don't, you know, they've taken the hinges out after the hinges being on the job site for 6 weeks. I don't have enough wood screws. You know, they're oil rub bronze, solid brass hinges. You know, there's no way to instantly make that happen. So think that through. Specify at the time of order. Bommer's also going to include some shims. They're also used to just separate the hinge leaves in shipping. But these perforated cardboard shims can be used to just move your door to where you would like it to be to better fit your opening. If it's a fire-rated door, do not use cardboard shims. If it's a fire-rated door and you need to shim the door, you need to use steel shims, of which, of course, we can supply you. This hinge is absolutely permissible for use on fire-rated doors. This hinge is listed permissible for that use because it is a bearing construction. It is a it is a base material that is approved, either steel or stainless steel. Ferrous-based steel, non-ferrous stainless steel. What you can't use is brass or bronze or anything outside of those two elements that isn't listed and labeled. If it's a continuous hinge, it has to have a label on it. As far as I know, it does. Hinges like this don't have to have visual evidence of them being compliant with fire code. They don't need to be stamped. However, spring hinges do. It's mandatory in code in NFPA 80, which is a standard. If the code picks up that standard, they have to actually have the UL or the designation and a listing number indicating that it's been tested and found compliant with the requirements. The reason I say that is because you can buy spring hinges. Doesn't mean you can use those on your fire rated doors. So be mindful of that, especially odd spring hinges. Bommer, the company is in about 1877 or so. The two brothers, Bommer brothers, they invented the spring hinge concept, and you will definitely see knockoffs of their hinges from lots of different sources. Be mindful. If you live in a city like New York and you have an apartment building that's 100 years old, for sure, you can very much count on seeing Bommer hinges everywhere. You're going to replace them with some knockoff hinge off the shelf. You better be looking for that stamp, that indication that it's a fire rated approved product. Not approved like we find it to be kosher, etc. It's been tested. And if you want to see something interesting, test a steel door fire test from Underwriters Laboratory. It's 3 hours of burn baby burn at 1800 degrees. And then after that, they take after 3 hours, they take a fire hose and hit the assembly with, I don't know how much PSI of water. And all the hardware and the doors and frame need to survive. And these hinges that haven't been stamped haven't survived that extremely excruciating test. I've known people that were either manufacturers of steel doors or manufacturers of hardware, and you spend $10,000 to arrange the test, and then you go to witness the test, and you're just a nervous Nelly because you want to make sure your hardware or your door passes the test. Because without the certification of the fire testing laboratory, you can't use that material on a fire rated door. The last thing I'd like to point out to you would be the Bommer logo. And right above it, it says Made in USA. That's a fact that Bommer is quite proud of, as am I to represent them. I would put Bommer's customer service up against anybody's customer service. I would put Bommer's shipping department up against anybody's shipping department. I would put their engineering department. That's an unfair fight. The engineering department there is second to none, literally. I've been to the plant, I've met the folks, and I've known them for a long time in my family for decades. And a deep appreciation is what I walked away with in terms of what it takes to make a hinge. I've seen steel doors manufactured and other pieces of it. I've seen roll formers create frames. That's all child's play, in my opinion, when it comes to making a hinge. That's a dastardly business because it's involved. And I really am appreciative of the opportunity to work with Bommer. Any questions on the LB8006 and a 450S in a 630 finish or any other Bommer product, please feel free to reach out to us. And thank you.